Many of you have been asking for a way to dynamically swap the meshes you're using in your building and have it also adjust dynamically to the size. So that way you can pipe whatever mesh you want and it'll, no matter what it is, it will actually work from the get-go. And that's what we're going to be setting up today. So here's what you are going to get at the end. The ability to have random modular pieces and for it to be able to change the seed of it without changing the actual design of everything, and for it to update with the actual wall size. So right now, wall size is 400. If we can set it to 500, 600, 200, it doesn't matter what you set it to, it automatically updates. And we can change the same thing with the height. We can make it smaller, or you can take it much taller, and it will all automatically scale and fit appropriately. So let's get right into it, and let me show you how to set this all up. In order for us to actually use the varying sizes of our meshes and get that information to populate it, as well as to really dynamically swap the building pieces that we're using, we need to use something that was introduced in 5.4, data assets. Now, data assets themselves are not new in 5.4, but for PCG, they are. So let's go ahead and set one up and start implementing the actual information from your static meshes to be used to actually control that wall. So to begin, I'm going to make myself just a new folder just to have everything kind of grouped in there. That's going to be part of the data assets section. In here, the first thing we're going to do is get ourselves a structure. Right click, search for structure or struct, grab a separate structure. I'm going to call it S_building components. Let's go open it up. And by default, this will look like this for you. I have my default values preferably on the right side. So this tab here, default values, I'll grab it and just pin it right here on the right so I can see the actual variables and the default values all in one go. This is much more preferred for me. So we're going to need a few actual things. We're going to know what the mesh is. So let's go ahead and name the first variable mesh. It's going to be of type static mesh object reference. And then we'll add two more just right away. The first one will be weight, and it's going to be of a type float. And this is just to say if we want one of the meshes to appear more often than the others. And another one I'm going to add now because we're going to be using it. And this is open back. And this is going to be a bool. Open back, basically, I'm referring to meshes that don't have something on both sides. So a lot of the Megascan's walls and windows don't have a back piece. And so in order to have it, for example, close that off, I want to say, yes, this needs a back piece, or no, this does not. So you can actually use meshes that have them and don't. Now in the default values, we can leave everything default except the weight. I would like to have the weight be a default of a 1.0, so that way it is actually appearing. But that is all we actually need in here. The next thing we're going to need is a primary data asset, which is kind of the base that holds the variables and the functions that are used in the data assets. We're going to right click and grab ourselves a blueprint class. And under all classes here, you want to search for primary data asset. And that's what we want right here. Select. I'm going to call this PDA for primary data asset underscore modular building. Now let's go ahead and open it up. Now this will look very much like an actual regular blueprint menu or like the PCG menu. But of course it doesn't have a viewport. It only has an event graph, no construction script. That is all we need. Really, we just need the variables in this case. So add a new variable. So we're going to need a few of them, starting with the regular walls. And the type is going to be of our struct. So I'm going to call it S_building components. And we want it to be exposed. So go ahead and hit the I icon, and it also needs to be an array. So right click on this S building components and it'll convert it to an array. And now we need a few other things. So this is the regular walls. We also have the unique walls that appear every second, third, fourth floor, etc. that we have in our system. So we want the detail walls. We'll make a new variable. I'll call the next one detail walls. Also, we want it exposed, and one more. And this is going to be for our floor and also exposed. That way we can populate the meshes for all of these in one go, and they're all going to be exposed. And we can always add more as we continue on. For now, that's all we need here. So now I can go ahead and create the data asset by right clicking and search for data asset and go ahead and select it under miscellaneous here. And we want it created based on the PDA modular building. So I'll search for PDA underscore modular building. And here it is. This can be the actual version of this asset. So I'll call DA for data asset underscore regular building. And you can actually customize this now to your heart's content. So if we open this, you can see we now have regular walls, detail walls, and floor, and we can add pieces into the array. You saw I have to add something for something to appear here. If you want to, you can come in here, press the plus button so you can have a default in here and populate the defaults if you would like. I'm not going to do that in my case. I'll leave it all on blank, but you can do that. So by default, it'll have something where you can start from. So let me go ahead and populate the regular walls. And for this, we're going to be using the windows from Megascans. I'm going to use the basic window type. The detail windows, I'm going to grab a different one, maybe with a balcony. And we can actually grab two variations here. So I'll grab ourselves a second one and search for window. And this is going to be the one with the top here, the top detail. And the floor is technically a roof, but that's okay. I'll grab ourselves a roof piece And there we go. Now, the other thing we want to do is check this on for all of these. Technically, they're all open back pieces. None of them have a two-sided full mesh. So I'll go ahead and just check it on for everything. And that is going to be our kind of baseline here. So now let's go into the PCG and start actually incorporating this and swapping out and gathering all the information, scaling in, everything else we need to do with it. So we'll start with the walls. Basically, we need to get the information from our actual data asset and then populate everything else inside of it. So we'll start with this mesh 1. If you're worried about, oh no, I don't have everything else here, is this going to be okay? Yeah, you could absolutely use this for your own setup with the data assets and everything. Don't worry. You just need to incorporate this part within your own system, and it's all going to be just fine. So for the time being, I'll go ahead and detach the static mesh spawner. And you can see our detail wall has disappeared here. We only have the regular walls left. And I'm going to need a few different things for this. And we want to scale it in actually all 3 axes. We want to scale in the height, the width, and the depth. So I'm going to grab all 3 of those variables first and get those ready for me. So if you come here, we have the wall height and the wall size. I'm going to duplicate those over to get actor properties. And we also have the wall thickness here. I'll duplicate it over. If you don't recall how to get these, you can right click, search for get actor property, and place your variable in here. And these are the same variables that we have exposed here in the blueprint. Now, aside from this, we actually need to have access to our data asset. Let's go ahead and set that up. Up top, if you go to graph settings and then to parameters here on the right under instance, hit the plus button, we can add a new property. I'll go ahead and rename this to data assets. Now, the name's not very important in terms of what it is. Well, what is important is to change the type. So from float, I'm going to click here and search for PDA modular building and select object reference. And now it changes the type. And under the drop down here under none, I can select my DA regular building. Excellent. That'll be our default here. Next up, we just need to get the information from it. So I'll right click, get data asset. That gets us our data asset, but now we need to get all the information from it. So I'm going to get property from object path. Now, the way this works is it gets only this property you specify. So right now, I'm going to be actually modifying the detail walls, right? So we want to actually just modify the detail wall section. And if we go under data asset, you can see it's under detail walls here. Now recall, in the actual PDA, we didn't put a space here. It's just detail walls like this. So in fact, I'm just going to copy this to make sure I don't make any spelling mistakes. And I'm going to change property name right here to detail walls and press enter. And you can see it is now actually just fine. The error has gone away. So effectively what we're doing with this is we're grabbing just this section of the data asset. If we want to grab multiple, we can, of course. We can grab also regular walls, floor, etc. But we just need the actual detail walls for this section here. So now we can grab our points and we want to match and set attributes, which will take the attributes from our data asset and we'll add them to the actual mesh points that we had before. If I go ahead and select it and press A, and I can go in the bottom left corner and select our PCG building here, I can see here all the way on the right, we have our mesh, we have their weight, and we have open back, and it's all being set here based on the input, which is great. This is exactly what we want. But now we need to go through every single point and actually scale it accordingly. And for that, we're going to need a loop because we need to go through every single point and check it against the information we have. So I'm going to go ahead and go into our loops folder, and I'll create a new PCG graph. This is going to be my PCG scale mesh to size. And I can just go ahead and click and drag it in right on top and just select create loop node. Now it doesn't have any inputs or outputs. That's fine. We can open it and get some, but really that's not enough. So we're going to double click on this node and we can open it up. And now we can set up the actual loop. So if I open up the input and output, we're going to change some stuff. Let's start with the output first because it's the simpler one. For the output, in allowed types, we just want to export points. Everything else is honestly fine. We can even keep it on out if you'd like to. And for our input, we want to also change the allowed types to be points as our first one, but we want to actually change the usage to be a loop because we want to loop on every single one of these points. Then we're actually going to need 3 inputs. So we'll add 3 pins and I'll go ahead and open them up. Now our points, I'm going to change the name of it to be points for a label. The label for the first section will be the width, second one will be the height, and the last one will be depth. And for each one of these, instead of allowed types any, we want allowed types attribute set for all of these. And under pin status, instead of normal, I'm going to say required for all of these because I want to make sure that we have something plugged in into all of these for it to work. Set them all to required, and there we go. So already in our regular PCG blueprint here, you could see we have this input. So we can actually plug in our stuff right now. We'll drag these over. Our wall size size is our width, our wall height is our height, our wall thickness is our depth, and we want to plug in the out points from match and set attributes into here, but we need something in before this. From here, I'm just going to scooch this over a little bit, and out of this out node, I'm going to search for attribute partition, and I'm going to open it up. Normally, we want to partition it by index, but in this case, we want to partition it by mesh, which is basically every unique mesh should get their own version of this. Search for mesh, press enter, because we want to scale all the meshes that are the same uniformly. We don't need to check every single point. We just really need to check every single point that's a different mesh. So by piping in mesh here, we can split it up and then plug this out point into our points node. Now, if I close this, you'll see the out actually disappears. For pin status, by default here is advanced. We'll just go change it to normal. And now if I open or close this, this out just stays there, which is a little more convenient. So now let's go ahead and actually start setting this up. Effectively, we can go through every single mesh, check the bounds of that mesh, and compare it to the size we have set up. Because if, for example, the mesh is 100 units wide and we want it to be 300, well, we want to scale effectively 3 times in that axis. And same thing for all of the axes. So really, whatever we do here, it's all going to go through a transform points node. And we're going to be modifying the scale min and max basically of it. And the output is just going to be outputted all the way to the end. Now, the scale min and max is all going to be the same, and it's going to be based off a vector. So I'm going to drag out of a scale min and search for make vector attribute, and the output type will go ahead and set it to be vector 3. It'll plug it into both scale min and max, and we can go ahead and just close this up. This is going to be our main input for all our calculations. So let's start with the first one, the width. The way it kind of works is we take our width that we have inputted and divide it by whatever the width of the actual meshes, and that will be the X, right? That is the width of it. But how do we calculate this in B? All we need to do is grab our points and then search for get attributes from point index. Now be careful not to get the set from index. You want to from point index, grab that. And the input source, instead of last, we want it to be our mesh, because that's what the information we want to get. You don't need to set output attribute name. All of this is fine. Drag out of attribute and search for point from mesh. I'm going to grab this one right here. And instead of overrides, open it up and plug it into static mesh. So what this does is it converts our mesh, our static mesh, into point information, but we can now break apart and read. So what we could do is actually get the bounds information. So by using the get attribute from point index again, I'll just duplicate it over and plug it in like so, and I'll duplicate it a second time. Now start showing a warning because it's doesn't find mesh, but we don't want mesh now. We want bounds max for the top and bounds minimum for the bottom. Go ahead and select it just from the drop down after hitting the plus button there. And now we've gone the bounds of our mesh. Now our mesh bounds are actually a vector. So we have 3 axes. Search for break vector attribute. And you want to plug that into both of these here from the attributes, not from the point. And now to find out the actual size of this mesh, because we just have the bounds, we just go ahead and subtract the large from the small. So drag out X, so search for subtract, and we subtract X from X, and we want to do the same thing for Y and the same thing for Z. So now we have something in all 3 axes that's calculating. Now, if you're unfamiliar with bounds are, it's basically the bounding box that encompasses your mesh. And the bounds minimum is just the smallest of the 3 points in the one of the corners, and the positive is the one that has the highest number in all 3 axes. That is the max. Now, this could be a negative value. Depending on how the mesh is set up, it could be negative. So I'm going to drag out and search for ABS for absolute, which will convert any negative numbers to a positive number. So that's perfect for us. That way we don't have any issues. And now we can grab this absolute value and plug it into B for X. And we need to do the same thing for the other 3 axes. So I'll plug in the absolute for the second one into B and duplicate again and plug in the last one into B. And this goes into Y and this goes into Z. For input A for the middle one, that is going to be our Y axis. So in our case, that is actually our depth, and the Z is the height. So I'll grab the height and plug that all the way through. Now I don't like the fact that these kind of are in the wrong order here. So I'll just grab index 2 and move it down below index 3. So it's just a little bit cleaner. And I'll add a few reroute nodes here to clean up this a little bit. But now we go ahead and actually scale this all accordingly. So if you go back our PCG building here, I can grab our static mesh spawner and plug it in. This will still actually just put our regular walls back in, not specifically the ones we have specified. To do that, change the mesh selector type on the right for the static mesh spawner from weighted to by attribute, and the attribute name we want is mesh. Now, if we come here, you might notice, well, there's a problem here. One, we have a gap here. That's because this mesh is a little bit taller, but I thought we were supposed to be scaling it that it fits this shape exactly. Well, one very important thing that is easy to miss is in the transform points, by default, it is on uniform scale. And we want to disable that. We want to scale each of the axes separately. And now with it unchecked, you can see each one of these is actually scaled. Even though this one was a bit shorter before, it is now matching in size. So if I go ahead and modify the wall size to be, let's say 200, you could see the original ones are all getting destroyed, but these actually scaled appropriately. So let's go ahead and apply the same setup to the other ones. So in our PCG building, we could go ahead and just duplicate all of this, but what I'm going to do, I'm going to select these 3 points and I'm going to convert them to a subgraph. So that way we don't have these additional points. We don't need them. I'll go ahead and right click on these 3 graphs, collapse into subgraph or Alt J. I'll put it in my subgraphs folder and I'm going to name it PCG underscore scale wall size. I'm going to clean this up a little bit to organize it. Now we can see the inputs here are a little bit out of order. Let's go ahead and kind of clean this up a little. So we have mesh 1 out and then random names. We don't like that. We basically want to do is set it to be width, depth, and then height. So I'm going to open it up, organize this a little bit. And now for our input 0, we're going to delete because that is actually a hidden one we don't need. Same thing with the output, input 0, we can go ahead and delete. And now for our input, let's go and change the labels. The first one is going to be our points. Label 1 will be our data asset. Label 2 will be our width, 3 depth, and 4 our height. Just like we had it plugged in here. So now it's a lot cleaner, which is great. So now we can actually use that same setup now for mesh 2. So what I'm going to do is take just these nodes right here and duplicate them down. But what I'm going to do is change the actual object from path because now it's no longer detail walls. These are our regular walls. So change the property name to regular walls. And now we can plug in the same variables as we had for the one above into this one and plug the points from mesh 2 into scale wall size. And I'll go ahead and delete this extra static mesh spawner. We do not need it. And now if we come here, well, it looks all correct. And if I change the wall size, so let's say 200, you can see all of them just get narrower and I can make them much wider and it's all adjusting accordingly. In fact, if I go really tall, really short, it doesn't matter. It all comes back to the right side, even the width. So if we come here and take a look at them, you can see the width here all lines up and I change the wall thickness. I can make it 50, 60, 80, right? It becomes thicker and thicker, which is perfect. There is one small problem with this setup though, and that is if I make the unique ones all the way on top, like so, you can see these are the unique ones. And if I go from above, the meshes for this are technically the right width. Their pivots are kind of in the wrong place. Because of this, on the inside, they're not actually perfectly flat here. So this is something to keep in mind. You want to make sure that your meshes are going to be the right thickness in the actual wall piece. It's fine that the pivots are out here or inside, but they want to be consistent. So while I can go ahead and change the thickness here, and you can see it all gets thickened properly, we're never going to be able to get rid of this gap. This is a modeling change that needs to happen. And that's just because I'm using 2 meshes that were not really built for interiors. Now, the last thing is we have this on the inside, and we don't like that. We want to have some kind of walls on the inside. So let's take care of this next. What effectively we need to do is go through every single mesh and check, does it have the bool? If it does, go ahead and copy a second copy of it on the other side. And if it doesn't, just continue on as you were. But that means we need to actually create another loop that goes through every single mesh like we did before. We'll go ahead and create a new PCG graph by right-clicking, search for PCG. As before, grab ourselves a PCG graph and call it PCG close open back walls. We're going to have a different version for the floor because it's going to need to be flipped in a different axis. So with our close open back walls, I'll go ahead and drag it in here and select a loop node and then just double click it to open it. Let's open our input and output. For input, instead of spatial types, we want points. And we want it to be a loop, and under pin status, we want it to be required. And for the output, we want the allowed types to be point as well. We'll go ahead and change the label on this for regular walls. And we want one other output here, and this is going to be our interior walls. And the type is also going to be point. And make sure to change the pin status on the first one from advanced to normal. So now this one's pretty simple. Just like before, we're going to get attribute from point index. Our input type is actually not going to be mesh this time though, right? Because we need to grab a different variable. We have ours called open back. So that's what we want to grab. So in our input source, I'll input open back. And now we want to do a branch. So right click, search for branch. And if you open it up, you get output to be as an input. And that's where we want to put this attribute to, because that is a Boolean attribute that is going to make it so it outputs to B. And then our input goes in, and then our output A goes to regular walls, and output B goes to irregular walls, because it either does A or B. And in both scenarios, we want the regular stuff to go to the regular walls, but we also want a second copy to go to interior walls. So we'll go ahead and grab ourselves a transform points here. Again, because I have this little issue here, and because of the way the pivot points are set up on this mesh, I'm going to make an offset of -50 here on the Y, and then I'm going to uncheck uniform scale and scale it in -Y in both minimum and maximum. And that is going to go into our interior walls. There's a nice simple graph here. So now before the static mesh spawner, we're going to need to plug this in. So just like before, we cannot plug this in directly. We need to get an attribute partition, but we want to partition it again based on the mesh. So we'll search mesh and attribute partition, plug that into our endpoints. And in my case, I'm just going to spawn the same mesh on both sides. So I'll go ahead and plug this in like so. I could take this and duplicate it down and plug it in the same way for the other ones. So now if we take a look, you can see it is actually has placed the walls on both sides. Now again, these ones have an issue, of course, that there is technically a gap right between them. That's because, again, it is not the full size of these, which is a problem. The other thing we might notice is there's a slight problem with this. There is a gap here. It doesn't do the corner. If I set like 1 to our wall thickness and make it very small, you can see it is almost perfect. You'd think maybe if it was 0, it would actually work, but the problem is then our wall thickness then would push inside and would potentially mess up with our floor. So what we're gonna do in the future part is just fill in this corner pieces wherever they appear. So don't you worry about that. That will be coming soon. But the main thing is we now have interiors on all of these. Now, these might not be the correct interiors you want, which is why we have these separated. If you want to, you can create a specific mesh for interior walls. And you can do the same thing like we did here and grab the specific assets and set that all up. Or maybe you could just use a regular mesh input if you always want the same kind of interior walls, for example. They just need to match up with your specific setup. And if you guys are enjoying the tutorial so far, I would love to hit the like button and subscribe if you're new for more awesome content like this. Get back to it. The next thing we want to do is actually modify the floors and ceilings. I'm going to detach the static mesh spawner. And now, just like we did before, I'm going to grab our get active property from object path and our data asset. I'll duplicate it down below. For this one, instead of regular walls, the property name will be floor. Again, because that is how we called it in our original PDA modular building. And then we want to match and set attributes using our original points. And now we want to go ahead and duplicate it also. But this one needs to be a little bit different than the open back walls, but we can go ahead off of these. So this PCG close open back walls, I'm going to duplicate it. And instead of close open back walls, I'm going to say close open back floors. I'll drag it out and create a loop from these and then open it up. The main difference here is in the transform points, I don't want to offset it on the Y. And instead of scaling it on the Y, I want to scale it in -1 on the Z, just like so. Nice and simple. And on the output, instead of regular walls, I'm going to call this floor, and on the bottom, I'll call it ceiling. So now I can go ahead and grab our attribute partition here. I'll just duplicate it over because it's already set up with our mesh index. Plug it in for match and set attributes. Plug that into our loop. And now our floor can go right into the static mesh spawner, but we want to, of course, change it from weighted to by attribute, and the attribute name is going to be mesh. And now if we take a look, well, everything looks right. We don't have the bottom ones yet because we have nothing plugged in. So if I duplicate this and plug it into the ceiling, you can see we now have the same material, the same object on both sides. So let's go ahead and just actually change the material for the ceiling so it'll be a little bit more noticeable. What you can do is open the template descriptor, and here you have override materials. I'll go ahead and click that, click the plus button here, and now I can override the material in that static mesh. I have this painted ceiling that I'm going to override it with. And now if we take a look, you can see it has now replaced it with this ceiling, and it's only on one side. But one thing you notice is it is still sticking out because, again, the pivots are just not in the right location. So clearly there's an issue with this one. But instead of this one, instead of actually modifying the offset, I'm going to show you how to offset the pivot itself. So here's my roof piece. I'm going to duplicate it. I'm going to keep the name the same as it was before. I'm going to name it _modified. So I know this is the different version of it. And if I drag it out, you can see the pivot point is here in the corner. And the actual pivot is not only in the corner, but is also actually just on top instead of on the bottom. Ideally, I would like to have it in the center and in the bottom here. So to do that, I'm going to go under selection mode, change it to modeling, and then go to X form. And now we can edit the pivot. So if we hit edit pivot, we can now move the pivot around. Now I'm going to manually move it everywhere if I'd like to. But what I'd like to do is just hit center, which will center the pivot, and then click bottom, which will move it to the bottom now of the object. So this is the bottom center. I go ahead, click accept. And now this version now has the pivot in the bottom center. So now if you open up your data asset and swap this out with the modified one, which should be right below, you can see when I hover over it, it says modified. So go ahead, select it. Everything looks correct, but now the offset doesn't work, right? So we need to now remove the offset actually. We don't need it anymore. So this entire offset min and max, I need to select it and delete it. Because the reason we were doing that offset was because the pivot point was not in the center like we were already using for everything else. If we take a look, we can go ahead and change the wall size to be whatever we want. Let's say 400. 600, it goes ahead and updates accordingly. And if we go down below and check our ceiling, it is now actually proper because we have actually adjusted our pivot point. If I move my camera right in between the two, you can see it is now perfectly right where it should be. Again, the same thing can be done for the walls out here, but we just need to make sure that the thicknesses between them are always consistent. And then we could move the pivot point, let's say, to the center and in the middle here, and then it wouldn't have the problem it does. As always, the project file for this will be available on my Patreon, where you can join these wonderful people here in supporting what I do. It really means a lot. And if you'd like, you can join the community in the Discord link in the description below, as always. Thank you again to the patrons. Let's get back to it. And one thing you might notice is this is pretty evenly spaced. Did we put a weight on this that we can control this with? Yes, we did. If we go to our PCG scale wall size, we did a match and set attributes here. And in here, there's actually an option for use input weight attribute, but there's also a match weight attribute. And that's the one we want. We want to select that and type in the name weight because that is the name of our variable. Now, nothing here has changed, but if I open up our DA regular buildings, our data asset here, I can go ahead and just specify 3 times for this balcony version. And now you can see the majority of them, well, are the balcony. There's occasionally a few of them that are not. Now looking at this, you can see we have the same design copied all the way up. It is actually never changing. And we can change the chance back to 1-to-1, but still you can see it always does the entire height. And this is a very simple fix. The reason this is happening is because when we're copying the points upwards, we're not changing the seed of the points. And because the seed is the same, it goes ahead and plays the same thing based on the seed. So in our PCG graph, under copy point up advanced, let's go ahead and open it. And in this transform points, we want to change recompute seed to be on. So for every point, it'll go ahead and just assign a different new seed. That's on the advanced one. We can also do it on the simple one as well. So we don't have this issue in the future if we need it. And we'll just recompute seed on the simple one as well. So now if I take a look, you can see it is no longer copying the same one up every single time. You can see, well, there's the one with the tops, the balcony, 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 but this one is tops. There's a few tops, then balcony, top, and this is now actually completely random. Now you might have noticed that we're still using the hard-coded 300 here for the size of our actual floors here. And we want to grab that information from the actual floor mesh. So to do that is very simple. We just need to reuse this scale wall size, and we can just plug in new information for all the stuff. We can go ahead and grab the seed, and we can grab all this get actor property from object path, duplicate it down here. Now we're not going to be using this transform points anymore because it's built into the scale wall size. I'm going to delete this. From the regular walls here in the property name on the get actor from object path, instead of regular walls, this is going to be our floor. And now we want to change the width, height, and depth. Now the width and the depth, which is basically the X and the Y, we want to be the same size as our wall. And our height is kind of the thickness of the floor, but we don't have a variable for that right now. So make a new variable. This is going to be our floor ceiling thickness. It is going to be a type float and is going to be exposed. I'll then compile it and I'll give a default value of something like 20. And I'll make sure that it can never go negative by putting 1 in the slider and value range of minimums. I'll also do that for the wall size and the wall height and the wall thickness. I don't want them ever to go 0 because with our math, that can cause issues. We also don't really want it to go negative either. So now we need to plug in our height. So I'll go ahead and duplicate our get actor property and I'll change this to be our floor ceiling thickness. So I'll go ahead and just copy the name of this so I don't get any mistakes. And I'll paste this into the property name and I'll plug that into our height. Now all of this can go ahead and go right after this copy points up. I'll plug it in here. Now over here, we're setting match and set attributes, but we no longer need to do that here because we're doing that inside of the scale wall size graph. So I can actually just go ahead and delete this and then plug it all the way through and scooch this over. So now you can see we actually have our ceiling and our floors. It's all looking good. We're no longer hard coding it, which means no matter what mesh we put in, and no matter what size we make our pieces, it will always accommodate for it, which is wonderful. Now, let's say, for example, we were happy with this, but I just want to randomize the balconies. That would be a nice option to have. Let's go to our BP building, and let's get ourselves a seed variable, which is going to be of a type integer. It is going to be exposed. And seed by default can be 0. That is completely fine. And what we need to do is basically change the seed on these match and set attribute nodes. They have a seed value that you can pipe in. So I'm going to right click, get actor property, type in seed in the property name, and plug that into our seed and close this up. Now we're also going to need this inside of our scale wall size. We're going to duplicate our seed property over here. And I'm going to open up our scale wall size graph and add ourselves a new input node. It is going to be labeled scene. The allowed type is an attribute set and is going to be required just like the others. And I'm going to open up our match and set attributes and plug our seed directly into seed and close it up. So now in our PCG building, we can go ahead and plug the seed into both of these. So now we can see we have this building and it's all great, but what if we wanted exactly the same place, but with different windows? We can just go ahead and change the seed. And now we get different designs of windows depending on the seed. So now we're able to completely change up the size of the buildings, change the height, change the width, and it all adjusts accordingly. And if we wanted to now, and we always can go down in our PCG node and under parameter overrides, we can always override this data asset with a different one that has different building pieces. So that way we can have building variations very easy and quickly. Since now it all scales based on the size of the assets that you input into it, which is perfect. Now, there was more I wanted to show you guys, but this tutorial has gone on quite long already, so we'll leave it for next time. And if you have suggestions on what specific things you'd like to see next time, let me know in the comments below. But thank you guys so much for watching. I hope you enjoyed it. Part 3 coming next week. If you really enjoy PCG and want to learn some more, check out this video right here for some more PCG goodness.